Hello, welcome to another Teacher Tobin tutorial. We're going to look at secondary storage, which is part of topic 3, computers, Edexcel, GCSE, computer science, and the curriculum specification code there is 3.1.2. This is going to be a short video, unlike some of the other videos in topic 3, which are quite lengthy. It's just really an introduction to secondary storage devices, making sure that you're not confusing them with primary storage, which we looked in the other videos as RAM or ROM, which is primary memory. So do not get confused with secondary and primary memory, okay? These are secondary storage devices. So this is an HDD hard disk drive. This one is a solid state disk. It doesn't move, and that's the key thing to remember there. It uses, and this is in the other video that I made on storage, this uses electronic, sometimes it's called NAND storage because it's using transistors that are stored electronically. There's no moving parts, and they're generally much quicker. The problem with them is that they have limited read and write cycles. So the more times you're reading and writing to them, the more chance eventually it will fail, and they have a finite lifespan. Magnetic storage disks are still used, especially in conjunction with SSDs, because even though SSDs are really fast, for archiving a lot of data, it's still better. You could get, for example, a 16 terabyte hard disk for, I don't know, about £200, maybe just over £200, which is going to be a lot less than a solid state disk. So you can get high capacity magnetic storage, secondary storage devices, which are a lot cheaper as well. So in data centers, you'll often find, in a sort of data rack where sort of websites are stored and iCloud stored and everything, you'll have maybe, I don't know, 4 or 5 secondary storage hard drives, and there might be an SSD in there to run the operating system. Because as long as the magnetic platters are not exposed to extreme heat or magnetic fields, they're generally they're fairly reliable, even though they're spinning around at something like 7,000 revolutions per minute. They're usually, and this is not part of Edexcel specifications, it's just general knowledge, they're usually stored in RAID arrays, where essentially the contents of one drive is copied to the other drive, and if there's a failure for one of those drives, the computer says, oh, replace drive 2, and you replace drive 2, literally just take it out of the drawer, put it back in, and it will copy the contents of it back into that. And you can have quite sophisticated RAID setups, which really have a lot of redundancy and allow for long-term archival backup. Because if you've got a photo backup from, say, iCloud, and you haven't looked at last year's photos for 6 months, they might be stored on a secondary hard disk like that and not creating a lot of wear and tear. So optical storage, you've got your CDs, you've got your DVDs, and you've got your Blu-rays, or Blu-ray dual layers, and they can go all the way up to 50 gigabytes now. So they're very cheap. The CDs were what I used to buy albums on. And they were about 650 megabytes at the time, enough to store an album, which incidentally is 44.1 kilohertz, and it would be 16-bit in terms of the bit depth there. But of course, you can have on DVDs or Blu-rays far higher fidelity recordings and movies and HD movies, etc. The speed is around about 50 megabytes per second, about that. So they're relatively slow, nowhere near as fast as these, which are about, I don't know, 3.5 GB potentially a second, It's huge. And these might be about 200 megabytes per second. Okay, so let's just talk a little bit about the advantages of optical storage then. So they're very cheap. You could get about, I don't know, 50 gigabytes. Use capital G for that. For, I don't know, 50p, 45p, something like that. Less than 50p, I'll put that. It's really cheap, and it's good medium-term storage or archival storage. If you know you're not going to look at a photo library for a long time, but you want to keep them, you can put them on optical storage, and they're going to be relatively stable for a long time. Okay. They're lightweight, they're highly portable, they can be posted. What's the problem with them? Well, they are relatively slow compared to other storage mediums. And they also are susceptible to scratches. If you expose them to sunlight too much, they could degrade over time as well, and they're potentially fragile. So, and then they've certainly fallen out of favour in relation to things like cloud storage in recent years. So magnetic drives, higher capacity than SSDs, or certainly far more affordable. I don't know, about £100 might get you, your 8 terabytes or a bit more than that. About 8 terabytes. Very reliable, especially if they're in RAID arrays. They can be the problems with them. They could be affected by magnetic fields, or heat. They're not portable. They're not good for portable devices, as we saw in a question in one of the other videos about a portable mower being used. It'd be far better to have the old iPods had mechanical hard drives in them, so you could actually hear it. I mean, if you tried ever using those peripherals, like a microphone to record things on those, you could actually hear the hard disk sound on it. So which is not ideal for a portable device at all. And they're spinning around at such fast speeds that they're quite difficult to recover from. They're not impossible to recover data from, but if there's mechanical damage, physical damage, it can be very difficult to recover data from it. And SSDs, far quicker, really fast, in fact, read and write speeds to them. They're good for portable devices, they're lightweight, and good for use in all modern tablets and laptops. Highly portable. Now they're very durable as well. They're quite reliable, except for the fact that they have limited read and write cycles. So there is a finite amount of times you can read and write to them before they will fail. Eventually they will fail. They will fail at some point. So it's good to have them in conjunction with other storage mediums. So, and really the big question is, what storage medium is best for long-term archival storage for like future generations? What are they going to be using? That could be an interesting question. So let's say, I don't really have any exact exam questions on this, but let's have a scenario where we might construct an expression, right? Construct expression to show, let's say 2 terabyte SSD disk can store the same as 8 GIB USB sticks, right? Let's just see if that's possible. So what would that be? 8 times. Oh, hang on, I haven't put the 8. Let's put 256. 256 GIB. So rushing ahead. So 8 times 256. That's going to give us our first part of our expression here. And then we could say that it 2 times 1024 GIB does equal 2 TIB. So obviously 2 times that is the same as that. So fairly straightforward question, but again, when you go to Currys and you're buying a disc, they're not selling you a TIB terabyte disc. They're using metric, and it's not based on the sort of base 2 system. So that's where a question like that could throw you off, even though intuitively you might know how to do it. You've got to remember that conversion factor. Right, I think we'll leave it there for this video. Quite a short video. Main takeaway is know a little bit of general knowledge about how these secondary storage memory devices are used, and don't confuse them with primary storage. Otherwise, that could throw you under the bus during the exam. All right, see you in the next video.